Hey guys, this is the answers for the 9.2b worksheet. So let's just hop right in here. You have 130 degrees, and first you need to remember where that is. 130 degrees is a little bit over here past 90, um, like right in this zone with the 135. So we're going to come back here, draw our axes, draw what we think is the 130. We put a dot at our initial point. We draw an arrow to our terminal side. We call it 130 degrees and we're done. 45 degrees at this point you should know is exactly half a 90. You shouldn't have to look that one up. Initial point, an arrow to the terminal side, and it's 45 degrees. Now, 30. Let's talk about this for a minute. Y'all know where 30 is. I know where 30 is. 30 is right here. No big deal. But this is a negative 30, so instead of going the positive direction, we drop down instead to 330 in the positive direction. So when we graph this, excuse me, it's this way down here. We draw our arrow from our initial point to our terminal side, and we say negative 30 degrees, just like that. Excuse me, sorry. So 172 is not quite 180 degrees, but it's negative, so it's going to be like, ooh, right there. So initial point, arrow to the terminal side, negative 172 degrees. Now, 200, I'm thinking like, I know obviously is bigger than 180, but I want to look at it. So here's 180, here's 210. So 200 is probably like right here somewhere. So let me get back here. 200 degrees was a little bit past the 180, maybe right there. Initial point, arrow to your terminal side, 200 degrees. Now, negative 300 degrees, let's see where positive 300 degrees is. Positive 300 degrees is right here. It's 60 degrees in. See, like there's 60 degrees left. So that means negative 300 degrees goes around with 60 degrees left. So it's actually at positive 60. So let me come back here because I know where positive 60 is. I got this. It's right here, the initial point, and then you go down and under to get around to your terminal side because it was negative. Okay, that's how we do these. Now, determining the quadrant is almost exactly the same thing. It's a little bit easier though because you don't have to be as precise about it. So you're just thinking like, this is 90, this is 180, 172 is definitely over here somewhere. That is quadrant 2. Now again, you're thinking like 90, 180, 270, 360, but here's the deal, that's a negative 315. So it's going to go all the way past 270 and be over here somewhere. That's quadrant 1. Now, 718 is a different story because that means you start at 0 and you go all the way around once. So I'm going to subtract 360 from that because I go around all the way once, and that leaves 358. So if I go again 358, I'm over here in quadrant 4. Same idea, 415. That means you go all the way around 360. So take your 360 and do a subtraction. That's 55 degrees left. Well, 55 is less than 90, so I'm going to be somewhere here. That's quadrant 1. Negative 63 degrees is just down here somewhere. That's quadrant 4. 135 degrees. 135 degrees. Well, here's 90, here's 180, so 135 is somewhere in here. That's quadrant 2. See, the difference between this and the graphical representation is we don't have to be precise. We don't actually have to know where 135 degrees is. We just have to know that 135 is between 90 and 180. Ooh, okay. Negative 700. Let's do this. We start at our initial point, but this time we go down because it's negative. It's still 360, so you're still like subtracting 360 from 700. That's 340. But you just have to remember the direction you're going, And 340 is bigger than 270 but less than 360, so we're over here in quadrant 1. Now 1020 is like the same idea. We're going to go around once for sure. That's 360. Do my math. What is that? That's 660, which means we for sure can go around again. Take away 360 and we get 300. And 300 is bigger than 270, so we're over here somewhere, I don't know where, in quadrant 4. Okay, 284. Let's do this. It's negative, which means it's negative 90, negative 180, negative 270, negative 284, somewhere over here. I don't know where, but that's quadrant 1. Okay, that was sad. We didn't have any in quadrant 3, but whatever. All right, converting radians and degrees. All of these appear to be degrees. Let's see. They're all degrees. Okay. So because they're all degrees, that's easy. Since they're all degrees, we put degrees on the bottom. End of story. That's what we do. Whoops, undo. Okay, so since this is a 120 degrees, we put the 180 degrees on the bottom. The pi goes on top. And now we have to go back like literally to what? 7th grade, 8th grade? And we're like, let's reduce this. So the zeros would cancel for sure. Zeros are gone. The other thing that cancels is the degrees are gone. Those degrees canceled. Now, what goes into 12 and 18? It's a 6. 6 goes into 12 twice. 6 goes into 18 3 times. And so my answer is 2 pi over 3. Done. Okay, same thing again. It's a degree, so since it's degrees, I put the 180 on the bottom and the pi on the top. I didn't really explain where that came from. Can you remember on our unit circle that pi was 180 degrees? That's all we're doing. And then we're canceling out the degrees. Okay, cancel your zeros and then you have 21 over 18 and something goes into 21 that also goes into 18. I think it's a 3. So 3 would go in here leaving 7 and 3 would go in here leaving 6, and so this answer is 7 pi over 6. All right, here, put the 180 on the bottom again. Since it's degrees, it's 60 degrees. And then we reduce the degrees, the zeros. Now we have a 6 and an 18. 6 goes into 18. Sweet. 6 goes into 18 3 times. So our answer is negative. We did not lose the negative. It's right there. Pi over 3. Okay, we're going to just keep going here. Stick it over 180. Put a pi on top. Cross the zeros and the degrees. 42 over 18. 6 goes in there. So this is 7 pi over 3. Stick your 180 on the bottom. That's a 180. Here's your pi. Cancel your zeros. That is negative 11 pi over 18. It doesn't reduce. 180 on the bottom, pi on the top. The zeros cancel, and I get 33 over 18. But that reduces by 3 to give you 11 pi over 6. Put your 180 on the bottom, put your pi on the top. 45 goes into 184 times. That's one of those, like 45 seems like it's really scary and confusing because you're like, that's such a weird number. But just remember that 45 is half of 90 and 90 is half of 180. So it's going to go in there all 4 times. But our answer is negative pi over 4. Okay, I'm kind of running out of room. I'm sorry. Here's my 180. There's going to be a pi on top. The zeros cancel and I have 15 over 18. 3 goes in there, and so I end up with 5 pi over 6. Okay, I get my 180 on the bottom, my pi on the top, cancel, cancel. 6 goes in there 5 times. 6 goes into 18 3 times. The answer is 5 pi over 3. All right, negative 135 degrees. It's degrees, so the degree goes on the bottom. 135 seems really scary until you look at your unit circle, okay? And then you're like, okay, hold on, this is a mess. Here's 135 right here. Oh, okay. So if 135 is right here, it's smack in the middle. So remember what that is? 45, 90, 135. How many units was that? 1, 2, 3 units. It says get back here. Wow, we're not even halfway done with this worksheet yet. Get back here, it's 3 units. So it's negative 3 pi over 4. All right, get your 180 on the bottom and your pi. Reduce out your zeros and your degrees. You have 45 over 18. That's a 9. 9 goes into 45. So it's 5 pi over 2. Last but not least is 210 with a pi over 180. The zeros and the degrees cancel. You get 21 over 18. That is negative 7 pi over, I'm having a brain thingy, 6. Okay, this is how we do these. I hope you already did them last night and you're doing a great job. Let's keep going. Now we're converting radians to degrees. You remember that 180 degrees is equal to pi, right? This time you have radians. So what you do is you put your pi on the bottom. So it's 180 on top, it's pi on the bottom. The pi's cancel. 6 goes into 180 30 times, and so we have 30 degrees. Done. It's radians again. So we have our pi on the bottom and our 180 on the top. The pi's cancel. 3 goes into 180 60 times, and 5 times 6 is 30. Put a 0 on it, and we get 300 degrees. It's radians, so pi is on the bottom and 180 is on the top. Pi's cancel. 2 goes into 180, 90. Don't forget that it was negative, so we have negative 90 degrees. Pi on the bottom, 180 on the top. Pi's cancel. 4 goes into 180 45 times. And remember we just did this. What was 3 45s? That was 135 degrees. Okay, we're just going to keep going. It's 180, it's pi, pi's cancel. That's 45, so it's negative 45. There's a 180, it's a pi. 6 goes into 180 30 times. Whoops. Sorry, technical difficulties. And so we have negative 150 degrees because the pi's canceled. Here it's pi, it's 180. 6 goes into 180 30 times again. 3 times 7 is 21, so this is 210 degrees. Hopefully at this point you've noticed that these reducings, like they're always the same numbers. And that's just how it's going to be. It's just going to keep being the same old stuff over and over again. Yes, you could use your calculator to divide 180 by 6, but you need to start practicing so that you can just do these reducings quick in your head. Okay, now we got to the hard one. It's a radian. And because it's a radian, there's a pi on the bottom. And so this is 180 on the top. You actually have to multiply. So that's 414 degrees over pi. Whatever that is your answer. So this one you do need a calculator on. And when you plug that into your calculator, you get 131.8 rounded up to a 5 degrees. Okay, so one more time what we did. They told us it was radians, so I knew pi had to be on the bottom. but the pi's didn't cancel. I multiplied 2.3 with 180 to get 414. It's still divided by pi. I plugged it in my calculator. I got degrees. I wrote degree on it, and I'm done. Okay, pi's on the bottom. Since it's radians, cancel, cancel, cancel. 30 makes 330 degrees. Here's another tricky one. Maybe pause and make sure you can do it. You guys were supposed to do this last night for homework, but I don't know if you did or if you realized it's the same. So maybe pause me right now. But what I'm going to do is multiply the negative 1.28 with the 180. That's negative 230.4. I'm going to put it over pi, and so I get negative 73.4 degrees in my calculator. Here's 180 over pi. Pi's cancel. 3 goes into 180 60 times, and my answer is negative 120 degrees. Okay, here's the last ones. We're going to want our unit circle for this. Pi over 6 I have memorized. I don't know if you have pi over 6 memorized already, though. You want to. You want to know where it is, guys. You have to. You have to memorize this stuff. Not even memorize it, though. Know it. Just know. Pi over 6 is 30 degrees. Well, where is that? That's quadrant 1. And 5 pi over 3? Well, if you don't know where 5 pi over 3 is, you got to go looking for it. 5 pi over 3, 5 pi over 3, where, oh, where could 5 pi over 3 be? There it is, 5 pi over 3. What quadrant is that? It's quadrant 4. Now, negative pi over 2, here's the terminal side. See, watch this, terminal side. Whoop. The terminal side of pi over 2 is right here. So it's like technically in quadrant 1. So if we're going to go negative pi over 2, our terminal side here is facing quadrant 4. So I'll accept two answers. I will accept the answer between 3 and 4, or the answer facing 4. You follow me? Let's do it one more time. It was negative pi over 2 from this direction. So it's facing quadrant 4, but it is also smack dab in between the two quadrants. So I'll take either answer. Okay, 3 pi over 4. Ooh, I have that one memorized too. 3 pi over 4, 3 pi over 4, hi-ho the dairy-o, where's 3 pi over 4? Right there, gotcha. Quadrant 2. This is how we do this. We're just looking it up. They're trying to familiarize us with the quadrants and with the unit circle by having us look at it. Okay, pi over 4. Well, we know where pi over 4 is. Pi over 4 is right here. But the problem was that was not pi over 4. That was negative pi over 4. So negative pi over 4 would be 45 degrees in the negative direction right here. Where is that? What quadrant is that? That's quadrant 4. Okay, 5 pi over 6. 5 pi over 6. It's negative, but we need to find 5 pi over 6 so we can figure this out. So 5 pi over 6, 5 pi over 6, I'm looking for 5 pi over 6. Here it is. 5 pi over 6 is in the second quadrant, but this is a negative 5 pi over 6. So instead, what I need is negative 150 degrees. All right, that is 30 units up here. So if I go negative 150, I go right here. Right here. What quadrant am I in? I am in quadrant 3. See, these are not meant to be tricky. They're just meant to get you thinking. 7 pi over 6. 7 pi over 6. 7 pi over 6. Ooh, I found it. It's right here. While I was erasing, I found it. It's in quadrant 3. Negative pi over 6. Well, I'm like, hey, I know where pi over 6 is. Pi over 6 is right here. And so negative pi over 6 is just right here, and that's in quadrant 4. This is how we do this. Now, this is tricky. 2.3 is a radian measure. But how many pi's is that? How many pi's? So you do 2.3 divided by pi, and so it's 0.73 pi's. Okay, it's 0.73 pi's. So you're like, what? Where's 0.73? Well, go to your unit circle, all right? 180 is pi. Pi is 3.14. So half of 3.14 is whatever half of 3.14 is. I think it's like 1.7. So if we're looking for 0.73, it's got to be here somewhere between 0 and 1.7. So it's quadrant 1. Yay, we're almost done. 11 pi over 6. You go to your unit circle and you find it. 11 pi over 6. Hey, I just found it while I was erasing. It's down here in quadrant 4. So down here in quadrant 4 is where the 11 pi over 6 is. Then we have 2 left. Let's do this. Okay, this is that tricky kind again. Negative 1.28 is a radian measurement. You need to know how many pi's that is. So you divide it by pi, and you get this gorgeous decimal number like this. Well, we just did 0.73, and it was in quadrant 1. So we're like 0.407 is for sure in quadrant 1, somewhere over here. Except it was negative. So that means we go down instead, and it's in quadrant 4. Okay, last but not least is 2 pi over 3, but it's negative. So find 2 pi over 3. 2 pi over 3, here it is. Found it. 2 pi over 3 is at 120 degrees. But I need negative 2 pi over 3. Negative 2 pi over 3 is right here in quadrant 3. This is how we do this, guys. You did a great job. I hope you're ready for your pop quiz. Have a good day.